to our lecturer, Dr. Arif, and our fellow cosmet. So we are from Group 1. My name is Fiona, and my other group members are Abdul Rahman, Amran, and Haishan. So today we would like to discuss about experiment 3, which is the application of the first and second law of thermodynamics. I will start first. Okay, so the first part in this experiment is abstract. Okay, this experiment was carried out to apply the first and second law of thermodynamics in various processes. Water with two different initial temperatures, hot and cold, are used to run this experiment. Okay, the temperature of hot water was recorded in each minute from t equal to 0 until t equal to 10t until thermal equilibrium is reached. At the end of this experiment, the temperature of hot water is decreased over time while the temperature of cold water is increased over time. And both water reach thermal equilibrium where both of them have the same temperature, which is between 35 to 36 degrees Celsius. And then the graph of water temperature for both hot and cold water versus time was plotted. Next, we will move to the objective. This experiment is conducted to apply the first and second law of thermodynamics in various processes. And for the introduction, thermodynamics deals with the interchange of energy such as heat and work between system and the surrounding, which occur when the system undergoes a process either heating or cooling. First law of thermodynamics states that energy cannot be created or destroyed, but it can be transferred from one location to another and can be converted to other form of energy. So, first law of thermodynamics is also known as law of conversion of energy. According to this law, all conversion of energy is possible. So, for example, when we boil water in an electric kettle, the electrical energy will be converted into the heat energy. Okay, the energy balance is maintained within a system. The balance is expressed as work, as all energy into the system are equal to all energy leaving the system plus the change in storage of energy within the system. From the second law of thermodynamics, we can conclude that when two bodies of different temperatures are brought into contact, the heat energy will flow from the body of high temperature to the body of the lower temperature. This is because heat cannot itself flow from cold water to hotter body without applying any work. So that's all from me. I will pass my presentation to my next member.
Assalamualaikum warahmatullahi wabarakatuh to our lecturer and then to all my friends. So my name is Abdul Rahman Mizalani. I will be continue to present about the theory for this experiment 3. So the first law of thermodynamics is referred to as the conservation of energy principle. So below is the basic calculation of the energy balance for the system. So E in minus E out equal to the delta E system. So delta U system equal to 0, and then delta U system equal to delta U hot water plus delta U cold water, so it is equal to 0, and then M, which is mass, will be times by the Cp, which is heat capacity, in bracket T2 minus T1 hot water plus MCP in bracket T2 minus T1 cold water equal to 0. So the Clausius statement of second law of thermodynamics stated that the heat can be transferred from hot to cold without doing work.
Assalamualaikum and a very good evening to Dr. Arif. My name is Muhammad Amran, and now I'll be explaining starting from the apparatus and components up until methodology. Okay, firstly, there are 6 main components that are used in this experiment. Okay, to start off, I will start with the kettle. The kettle is used to boil the water. Next, we have thermometer, which is used to record the temperature, a stopwatch to record the time taken. Then we also have a balance, which is used to measure the weight. And lastly, we have a small beaker and a big container that are going to be filled with cold and hot water. Okay, next, as you can see in the figure 1 below, a schematic diagram of the experiment is shown where the hot water in the small beaker is placed inside the container filled with cold water. Okay, now moving on into the methodology part. Okay, firstly, we use the kettle here to heat up the water. While we wait for the water to be heated, we measure the weight of the empty beaker. After that, we pour the hot water from the kettle right into the beaker and we measure the weight of the hot water. Okay, next. We then carefully place and move the small beaker into the container. The next step is we had to make sure that the cold water has not entered the small beaker filled with the hot water. Okay, after that, we then slowly fill the container with cool water, and then we have to fill the cold water to the same level of the hot water. And then we measure the weight of the cold water. From this point, we then place two thermometers, which first was placed into the hot water and the other thermometer was placed into the cold water. Last but not least, we use the stopwatch to record the temperature of both water for each minute until they reach the same temperature as in table 1 shown below. Okay, so that's all from me. Thank you.
For this experiment, I will explain about the result part and the discussion part. So as we can see in the slide, this is table 1, which shows that the temperature of hot water and the temperature of cold water in degrees Celsius. And before we see the temperature, the table 1, we shall see the constant for this experiment, which is heat capacity of water Cp is equals to 4.187 kilojoules per kilograms Kelvin, and the mass of hot water used is equals to 0.203 kilograms, and mass of cold water used is equals to 0.730 kilograms. So as we look at the table 1, for every in this experiment, for every 20-minute interval, for every 1-minute interval, the temperature of hot water and the temperature of cold water is recorded by using a thermometer, by placing it in the specific beakers, which is the hot water beaker and the cold water beaker, and then the temperature is recorded for every 1 minute. So at the initial part, the initial temperature of hot water is equals to 85 degrees Celsius, and the initial temperature for cold water is equals to 28 degrees Celsius. So as we can see in the table, the temperature of hot water decreases as the time increases. This is because the heat is absorbed by the cold water, so heat is released from the hot beaker. So as we can see, the another column, which is the temperature of cold water, it increases as the time also increases. So this is because the heat is absorbed and transferred to the cold water. So at the final minute, which is the 20th minute, the temperature of hot water is equals to 36 degrees Celsius, and the temperature of cold water is equals to 35 degrees Celsius. So at this state, it is stated that both medium hot water and cold water is thermal equilibrium is reached or achieved at this 20th minute. Now I will explain the graph for this experiment. So there are several graphs, especially two graphs. So now we're looking at the the general graph for both medium, which is temperature of hot water and cold water, versus time. So for this both medium, the curve looks like this in this slide. So when we look specifically the graph 2, in which it explains the temperature of hot water versus time, and this graph looks like the curve looks like irregular shape. So in which it gives a best field line with an linear equation of y equals to 1.8078x plus 64.7792. So the gradient is a negative value, which is negative 1.8078. So in this case, is because it gives a decreasing curve. So the decreasing curve is because of when the time increases, the temperature decreases. So for the next graph, which is graph 3, this explains specifically for temperature of cold water versus time. So in this graph, in this heat curve also has a plotting points of irregular lines, so it's not that stable also. But it also gives a more of an accurate best field line, in which with the linear equation of y equals to 0.361 plus 29.104. In this case, the gradient is in positive value, so this is because the temperature of cold water increases with time. So now I will explain about the calculation part, and in where we need to calculate the energy change for both the hot water and cold water. So based on the first law of thermodynamics, the energy balance of a system is equals to the difference between the energy entering and the energy releasing out. So the only energy present is the heat transfer, U. So the change in U system is basically equals to 0 based on the energy balance. So other energy such as kinetic energy is not involved in this experiment because it is in static position. So the heat energy in a system is equals to the mass of the medium times by the heat capacity of water, and then the change in temperature, which from final to the initial. So for both hot water and cold water. So let's look at specifically for the energy changes of hot water. For the energy changes of hot water, we need to times with the mass of the medium of hot water, which is equals to 0.203 kgs, and the heat capacity of water, which is 4.187, and then the change of temperature of hot water from final to initial. So from final is 36 degrees Celsius, and then in initial is 85 degrees Celsius. So for both temperatures we need to calculate in Kelvin. So as a result, the energy changes for hot water is equals to negative 41.65 kilojoules, which also state as energy out. For the next medium, which is the cold water, so the energy changes for cold water is also equals to the mass of the medium of cold water, which is 0.730 kgs, times with the heat capacity, which is 4.187, and then the change in temperature from final to initial of cold water. So the final is 35 degrees Celsius, and the initial temperature is 28 degrees Celsius. So for both temperature we need to change into Kelvin, and then as a result we will get positive 21.40 kilojoules, which also known as energy in. Now I will explain about the discussion part for this experiment. So based on graph 2, temperature of hot water versus time, it contains a negative gradient value, which is 1.8078. In this case, the temperature is decreasing with time, while for graph 3, temperature of cold water versus time, it has a positive gradient of 0.360, which explains that the temperature is increasing with time. So from this experiment we can observe that as time increases, the temperature of hot water decreases while the temperature of cold water increases until thermal equilibrium is reached. So this shows that there's an exchange of energy between these two mediums, where the energy released by the hot water is absorbed by the cold water. This proves the first law of thermodynamics, in which energy cannot be created or destroyed. So, but this energy can be transferred from one form to another form during a specific process. So, based on this law, the energy in a system is always conserved, and the net energy is zero when it reaches a equilibrium state. So, since the experiment is being conducted in an open system, therefore not all heat will transfer to the medium. To the Not all heat from the hot medium will be transferred to the cold medium. Some heat might be considered as a heat loss, so it will lost to the surroundings. So next, the based on the graphs, so we can observe that the trend line of the heat curve uh, describes the heat transfer. So they it shows that without the use of other external energy, heat can be transferred from hot water to cold water easily. So the result obtained from the experiment achieves the closest statement, and the closest statement in the theory part, which is the energy balance, and it obeys the second law of thermodynamics. So the second law of thermodynamics states that the heat is transferred from high energy level to a low energy level. So or also can be said as from a heat transfer from a high temperature body to a low temperature body. So by using the energy balance of heat transfer, the changes in energy for both the hot and cold water medium can be obtained. So amount of 41.67 kilojoules of energy is transferred out from the hot water beaker, and while for the cold water, an amount of 21.40 kilojoules energy is transferred into the beaker. So the energy transferred out from the hot water is obviously is not equal to the energy transferred to the cold water. So therefore there's a remaining 20.25 kilojoules of energy which is lost to the surroundings. So this might due to the beaker, so the beaker is not well insulated, therefore heat can be lost to the surroundings, and it also can be due to the environmental reason, such as the experimental room in which the fan is on. So there might be some errors occurred in this experiment. For example, if the thermometer touches the wall of the beaker of hot water, the temperature taken will not be that accurate. So because this temperature is absorbed by the cold water surrounding the hot water beaker, so hence parallax error also can be occurred in this experiment, in where position of the eye is not perpendicular to the reading of the thermometer. So speaking of thermometer, thermometer also can cause an faulty reasons. So for such as the incorrect calibrations for when using in this experiment, so it can affect the reading of temperature for the both medium hot water and cold water.
Thank you to Aisha. So now I believe that we have come to the last part of this experiment, which is the conclusion. So this experiment is considered as success as the objective of this experiment is achieved. From the experiment, temperature of hot water is increased over time while temperature of cold water is decreased over time. The plotted graph proves that the water reaches equilibrium at minute 90 to 20 when temperature of both hot and cold water is between 35 to 36 degrees Celsius. From this result, we can conclude that there is an exchange of energy between these two mediums, where the energy released by the hot water is being absorbed by the cold water. And by using the energy balance of first law of thermodynamics of heat transfer, the change in energy for both the hot and cold water can be obtained. The amount of 41.65 kilojoules of energy is transferred out from the hot water, and 21.40 kilojoule of energy is transferred into the water. The transfer of heat from the hot water to the cold water proves that the second law of thermodynamics is valid. So that's all from us. Thank you.